Hello guys, welcome to the channel. Today we are going to discuss the topic cumulative distribution, and it can be written as CDF in short. Now we can look the definition. The cumulative distribution function CDF, and it is denoted by capital F of x of a discrete random variable x with Pm of P of x is defined for every number x by capital F of x equal to P of x less than or equal to small x. So you have to note this. This is the main thing. This is the main thing you have to study about cumulative distribution, and it is denoted by capital F of x, and it is equal to P of capital X less than or equal to small x. For any number x, capital F of x is the probability that the observed value of x will be at most small x. So you should study this thing. This is the main definition of cumulative distribution. Now we can explain cumulative distribution using an example. As the name, as similar to the name, cumulative distribution is the adding up of probability mass function. So consider this. A store carries flash drive with either 1 GB, 2 GB, 4 GB, 8 GB or 16 GB of memory. The table gives the distribution of y, and here y is the random variable, and it is defined as the amount of memory in a purchased drive. Y takes the values 1, 2, 4, 8, 16. That is 1 GB, 2 GB, 4 GB, 8 GB and 16 GB, and corresponding probability is given. So what is this? Values of random variable y with corresponding probability. This is the PMF. So PMF is given. What do you have to find out? You have to find the CDF. So from this you can see this is the PMF. We know that PMF is the list of the values of random variable along with the probability. So this is PMF. Now you have to find out CDF. That is cumulative distribution function. CDF. What is the formula? CDF is denoted by capital F of x, and the formula is P of capital X less than or equal to small x. So we can rewrite this according to random variable y, that is P of capital Y less than or equal to small y. So first we can find out f of 1. F of 1, what is f of 1? P of capital Y less than or equal to 1. So what is that? It is equal to P of less than or equal to 1. Less than 1, nothing is there. So P of Y equal to 1. That is, what is that? P of 1, which is equal to 0.05. What about f of 2? Capital F of 2 is equal to P of Y less than or equal to 2. So this is equal to P of Y equal to 1 plus P of Y equal to 2. So this is equal to P of 1 plus P of 2, that is equal to 0.05 plus 0.10, that is equal to 0.15. Similarly, we can find f of 4. F of 4 is equal to P of y less than or equal to 4. It is equal to P of that is equal to P of 1 plus P of 2 plus P of 4. That is P of 1 plus P of 2 plus P of 4. That is 0.05 plus 0.1 plus 0.35. That is equal to 0.5. that is equal to 0.5. Now what is f of 8? F of 8 is equal to p of y less than or equal to 8, that is equal to p of 1 plus p of 2 plus p of 4 plus p of 8, that is equal to, what are the values? 0.05 plus 0.10 plus 0.35 plus 0.40. So that is equal to, what is the value? 0.9. So now f of 16. F of 16 is equal to, what is f of 16? P of y less than or equal to 16. It is P of 1 plus P of 2 plus P of 4 plus P of 8 plus P of 16 is equal to, what is the total probability? That is equal to 1. We know that total probability always equal to 1. So these are the cumulative distribution function at each point of y values. So you can draw one more column here and you can write uh, as a table, or you can write as a function model. So anything is okay. So now we can write CDF as a function form, that is capital f of y is equal to, what are the values? It is 0 when y less than 1, 0.05, it is 0.05 when y less than or equal to 1, that is 0 less than y less than or equal to 1, that is 1 is included but 0 is not included. One minute. F of 1 equal to, okay, this is when y less than 1. So this is y less than 1, it is 0. This is 1 less than or equal to y, 1 less than or equal to y less than 2. Now next is 0.15 when 2 less than or equal to y less than 4. Then next is 0.5 when 4 less than or equal to y less than 8. The next is 0.9 when 8 less than or equal to y less than 16. Then 1 when y greater than or equal to 16. So we can write CDF as a function form, or you can write as a table form, like you can write capital F of y here and just write the values 0.05. Then what is the next value? 0.15, then 0.5, 0.91. So you can write like this, or you can write as a step, means function form. Okay. Now there is a note, f of 2.7. This is not an integer. So how we find the CDF of this value? So we can take f of 2. That is, here we take least possible value of 5 to the left of 5. Here 2.7. 2.7 will be in this area. This is 2. Then 2.7 will be in this area. So the left of 2.7 is 2. So we write this as P of 5 less than or equal to 2, that is equal to 0.15. So It is a note. Consider another example, f of 4.3. How do we find out f of 4? That is p of y less than or equal to 4. What is p of y less than or equal to 4? That is 0.5. Why we take f of 4 in the case of 4.3? That is, this is 4 and 4.3 will be in this region. So left of 4.3 is immediate left of 4.3 is 4. So we can draw the graph of CDF function like this. We could take step function like this. So take the values of y in the x-axis and CDF in the y-axis. So from this function, it is given that the value of the CDF is equal to 0 when y less than 1. That is, let this be the point 1. So up to this point, the value of CDF is, or capital F is 0. At the point 1, the value become 0.05. Look here, the point 1, the value become 0.05. So from the point 1, the value became 0.05. That is, there is a jump from 1. That is 0 to 0.05. So there is a jump. Similarly, 0.05 up to 2. It is up to 1 to 2, it is 0.05. But at the point of 2, it becomes 0.15. Then again a jump from 2 to 4. So this is called step function because CDF gives a graph of step function. So it have a jump at every possible value of y or x and will be flat between possible values. So this graph is called step function. Now we can do one question related to CDF. Where the question, the possible values of a discrete random variable x are 1, 2, 3, 4, 5. If all values are equally likely, find the PMF and CDF of x. Also find probability of 2 less than or equal to x less than or equal to 5. P of x greater than 3. P of x is an even integer and you have to draw the graph of CDF. So the values of random variable is given but PMF is not given and also you have to find CDF without the table of PMF. In the previous example, we have PMF table. So we have a hint that the values are equally likely. So we know that it is given that x takes the values x equal to x. So x equal to x takes the value 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So probability of x equal to x. It is not given, but there is a hint. All values are equally likely. Equally likely means all are equal. So the probability should be equal. So this is 1 by 5, 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 and this is 1 by 5. And all probabilities are greater than 0 and the total is 1. So we can write the CDF as a table form or you can write it as a function form. But here I am going to write as a table form. So what is the value of f of 1 here? That is 1 by 5. This is what is 2 by 5. This is 3 by 5. This is 4 by 5. This is 5 by 5, that is equal to 1. This total probability equal to 1. So this is the table of TMF and CDF. So from this example you can see that, or from this question you can see that CDF is the adding up of TMF. In reverse wise, TMF is the subtraction of CDF. Okay. Now do the first question. P of 2 less than or equal to x less than or equal to 5. So first problem, P of 2 less than or equal to x less than or equal to 5. Here 2 and 5 are inclusive. So P of 2 plus P of 3 plus P of 4 plus P of 5. So what is the answer? It is 1 by 5 plus 1 by 5 plus 1 by 5. So the answer is 4 by 5. Now second question, P of x greater than 3. P of x greater than 3, that is P of x greater than 3 means greater than 3, 3 is not included. So P of 4 plus P of 5, that is equal to 1 by 5 plus 1 by 5. This is 2 by 5. Now the third question, P of x is an even integer. P of x is an even integer means P of x is an even integer. So what are the even integers here? P of x equal to 2, 4. That's all, 2 and 4. So 2 and 4. So that is equal to, also equal to 2 by 5. Now the last question, you have to draw the graph of CDF. So for drawing the graph, you can take the values of x in x-axis and function values, that is cumulative values on y-axis. So 0, 1, 2, 3, 4, 5. So 1 by 5, 2 by 5, 3 by 5, 4 by 5 and 1. So from 0 to 1 it is 1 by 5. Then there is a jump. Here also a jump. Then there is a jump. This became 1. So this is the step function graph of the CDF. I hope this is clear. If you have any doubts, you can comment your doubts in the comment box. And thank you for your patience. Thank you all.